Hi guys, my name is Michal Privoznik. I work for Red Hat. I'm a senior software engineer there. I'm on Red Hat's board for nearly 5 years now. And for all of the time, I've been working on Libvirt. And I feel slightly bad about my topic for the talk after all the nice things that Jiří told about me. But today I will tell you something about what we did wrong in Libvirt. But more importantly, I will analyze why we did that, and hopefully I will give you some advices so you don't have to necessarily repeat those mistakes in your projects. So, before we start, just to make sure that we are more or less on the same level here, what's Libvirt? Libvirt is a standard C library for managing virtual machines. So even though we are written in C, we do have bindings to many languages out there, like Perl, Python, Java, Ruby, whatever you name it. We do provide a stable API, which means whenever an API was released, we keep it around for the rest of Libvirt's lifetime. And by API, I do not necessarily mean just C functions, but every other way that Libvirt communicates with the outside world. You've probably noticed that we communicate in XML or via XML. We do provide multiple hypervisors. As Jiří pointed out, QEMU is our most intense developed driver, but we do provide other hypervisors like Zen, VirtualBox, ESX, UML, user mode Linux, believe it or not. Linux containers, of course, and others. When it comes to launching your virtual machines and playing around with them, you need to, or you may want to prepare the host environment for that. Pre-create some virtual interfaces or something like that. So that's other side of Libvirt. We have a very strong host management system as well because we need to. Just a very quick introduction into Libvirt Internals. This picture will show you what is basically done under hood when an API is called. So we have an application here which suddenly called an Libvirt API. As you will see later, every API has an argument. Either directly it will get a connection object, or indirectly it will get another object where the QEMU, where the connection object is hidden indirectly. From the connection object, we will see the URI to where you are connected to. In this particular case, we see that you are connected to a Linux container running on a distant host, which means that the request is handled by our remote driver, which does nothing more than just pack all the arguments into a single packet and send them over the network to the distant daemon running on a distant host. Here, the daemon will unpack the incoming packet and hand it over to the actual driver where all the interesting work takes place. Once the driver is done with the request, the flow is basically reversed, and the remote driver on the client side will receive the reply. It will pair the incoming reply with the request sent earlier, because it already may have sent another request to say this different daemon, and it will yet again unpack the packet, deserialize the reply, and for some reason my notebook, never mind, and it will hand over the control to the application. So let's get started. Imagine you have a domain running, and you want to shut it down. So what are your options? What will you do? Any suggestions? Do I hear WereShutdown somewhere? No? Yeah, so this is basically one of the options. You may call WereShutdown, which will basically boil down to calling domain shutdown. You give it a domain pointer to work with, and Libvirt will somehow magically shut down the domain for you. But hold on a second. There are multiple ways how you can shut down a domain, aren't they? For instance, you can press, or in the real world, you can press the power button on the case, which will initiate, an ACPI event to which ACP daemon will hopefully respond somehow. Or you can have a small program running within your system, which will initiate the shutdown for you. But there's no way how you can choose these two approaches with the current API. So we had to create a new API, domain shutdown with flex, which gained the flex argument, where you can select all the approaches that Libvirt should undergo when trying to shut down a domain. This actually was an important example because after this, we've made an internal rule, so to say, that every new API must have the flex argument, so it's in some sense extensible for the future. You could say this is just an isolated example that I've intentionally picked up, but it's not the case, as you will see on the next slide. So yet again, imagine you have a domain running, but for some reason it starts misbehaving. It's in the wrong state for some reason. Luckily, you are a hypervisor developer and you know something about it. So you want to, get under hood. You may want to get a CoreDump. Luckily, Libvirt has an API for that. You give it a domain to work with. You tell where the CoreDump should be saved, and you give it some flex, which basically tells what to do with the domain once the CoreDump has been done. For instance, whether the domain should be kept running, or whether it should crash, or since you are going to write a lot of chunks of data, you may want to bypass the file system cache, and something like that. But hold on. Many hypervisors have ability to choose many formats of the CoreDumps. And yet again, that's something you cannot really do with the current API. There's no argument to do that. For instance, QEMU can take, Zen can take CoreDumps in, say, raw files or apply multiple compressions to it. So we had to invent a new API, domain CoreDump with format, which gained a new argument, this one, where you can choose the corresponding argument. What's even worse, not only we've missed the boat on the format, we've missed also both what does to refers to. Where the CoreDump should be saved. Does it refer to the client side or server side? Should the path be absolute or relative? If relative, then relative to what? So that's one set of mistakes we did. The second set of mistakes that we did, and let me just, short crash course into Libvirt's history. Libvirt started initially as nothing but a Zen wrapper, which wrapped some subset of Zen APIs into C world. And later, as many hypervisors were developed, Libvirt gained support for them as well. For instance, when QEMU showed up, we've written driver for that. Then LXC came around, and yet again, we've gained support for it. But this development has left some marks on our APIs too. So for instance, WereDomain create. This is dated back to Zen-only days. And actually, this is the reason why we refer to virtual machines as domains, because in Zen world, you have domains, not virtual machines. So yet again, you have WereDomain create, because in Zen you just launch a guest and that's it. But later QEMU came around, and you were suddenly able to launch a guest into a post state, for instance, say. Yet again, there's no way how to do it with the current API, is there? So we invented a new one. WereDomain create with flags, where in flags you can send multiple things to do with the domain once it's launched. Then later, after some time, LXC came around. And these Linux containers have really nice feature that you can pass file descriptors into it while it's starting up. So yet again, a new API, WereDomain create with files, where you can pass both file descriptors, an array of file descriptors, and you have a flags. Fortunately, this API is future-proof enough, so we don't have to invent a new one in foreseeable future. I'm holding my finger crossed. Oh, yeah. This is another example, and actually it's a very important example that have made us change our minds. So let me just quickly explain what's going on. We asked Libvirt to get us the number of currently running domains. Then we try to allocate an array to hold the IDs of the domains. And then we ask Libvirt to fill in the array with the IDs of the domains. After that, we iterate over the array and looking up the domain and hopefully do something useful with the running domains. I don't know, for instance, gather some statistics or whatever. One question, what's wrong here, beside the fact that I'm not checking, obviously, for errors because, it's an example after all? Would it help you if I tell you there are 2 races? No? So the first race is here in the first block, and the second one is in the second. So where's the race? By the time I'm allocating an array to hold the IDs, another domain just could have been started, which means at the third line, I will not get the full list of running domains. And the second race is here because by the time I'm iterating over the array, and by the time I will get to the last element in the array, the domain may have been already gone. And this is something that you cannot really, client cannot really, avoid doing because there's no way for a client to do this atomically. So we have changed our minds in that sense that we've invented a new API that will allocate an array for you. And this is, we've tried to resist that, but this example has made us change our minds about that. So we have a new API which will do all of these atomically for you. Oh, yeah, this is actually my personal favorite. I believe many of you here know some C, at least to some extent. So what does calling free over a null pointer in C do? Nothing. It's perfectly valid. You can do that. But it's not the case in Libvirt. You have WereDomain free, which for some reason, historical reasons, will calls an error when called over null. And to make things worse, we are not even consistent with our free APIs, because another public free API we have, WereDomain interface free, is perfectly okay when called over null. There has been plenty of discussion on list whether we should change it finally or not. But I think that we cannot really change that because somebody may have been relying on this erroneous behavior. Well, we will see, maybe. Oh, yeah, bad naming. As Eric already pointed out, what would you think that destroying a domain will do? The name suggests that it will completely destroy the domain without leaving any traces of it, but nothing can be further away from the truth, because if your domain is persistent, it's merely like plugging the power cord of the domain, which means shutting it down, not gracefully, but shutting it down. Yeah, and another example from the recent future, which brings us to XMLs. In domain XML, you can have the controller, and you can choose the type of it. For instance, whether it should be, SATA controller, USB, PCI controller, and such things. Then, for PCI controllers, you can choose, well, not model, but this is something that was mistakenly named as model because, the PCI Express root port is not really a model of a controller, is it? Therefore, we had to invent a new sub-element just to refer to actual model. Which brings us to domain XMLs. This is just really a placeholder because I could talk for a really long time about our mistakes in domain XMLs or in other XMLs for, I don't know, network or something like that. Just a personal note, I've tried to set up a NUMA guest recently, a few days ago, and I had to edit domain XML on 3 different places, which is not a very pleasant thing to do. But I guess if you've seen our domain XML at least once, you certainly know what I'm trying to tell you here. And I believe my colleagues will really agree with me on this slide that this is, well, whenever you are trying to introduce a new feature to Libvirt, it's sometimes required to rewrite a significant portion of the code. But enough of the bad stuff. Let's talk about something bright. So what we did do right? Firstly, there are plenty of things to talk about too, but I will just pinpoint a few. I think one of the best things that we've done is that we keep our internal, the majority of our internal APIs is internal. When Libvirt tries to start a domain or during its lifetime, it has to spawn multiple system commands. For instance, just only when setting the bandwidth limiting control over virtual interfaces, this is done via constructing the TC command line and spawning it, and yet again, just to construct some bandwidth limiting tree. But for spawning the commands, we have grown really powerful subsystem to which we refer to as WereCommand. And there has been plenty of requests, either IRC or the list, that we should make the WereCommand public for others to use as well. Personally, I don't think this is something that we want to do, because once we do that, the vir command APIs are just written in stone, and we cannot change them. But the fact that others are requesting for it means that we have done a really good job there. The second interesting point is internal objects. If you recall all these APIs I've shown you, they don't really take object itself. They take just a pointer to the object, which means the internals of the object are kept private, and we can change them whenever we want to. And we really did that. For instance, the virConnect object has been adjusted more than 20 times. Well, after 20 times, I've stopped counting. So let's analyze what was the source of the mistakes. Well, firstly, as I've already outlined, the historical reasons. The set of the hypervisors that we wanted to support has changed during the time. Moreover, so did the requirements, which means it's really hard to, whenever you are introducing a new API, it's hard to follow or to, follow any software engineering methodology to do the proper analysis and design. And of course, we struggle with some, we don't have many developers on some drivers. Some drivers are really just one-man show, for instance, and some hasn't been touched in a really long time. For instance, VirtualBox that has been touched for years, or the user mode Linux, which means since majority of us work on QEMU driver, that whenever you propose a patch or an API that fits into a QEMU world, you can be fairly certain that it will get in, although it may not as well fit into, say, I don't know, VirtualBox world or something. But the problem is there's nobody to tell you that. And then I really have to mention that the pressure of downstream releases. We have some situations when we've pushed an API without an implementation, and just only during implementation it occurred that the APIs were not as well designed as they could be, and we had to work around that. So, but now more generally, not just into Libvirt itself. With traditional, what's the difference between traditional and open source? In open source, it's really hard to follow any traditional software engineering methodologies. For instance, in traditional software, you can follow a waterfall model or something similar. It's not the case in open source because, for instance, in waterfall model, the testing is done only when development has finished, or the development starts only after design phase have finished. In open source, it's done all at the same time. And moreover, open source software is able to go back and forth in these models because, for instance, if it turns out during testing phase that something is broken or some API is not good designed, you can go back into design phase or into analysis phase and redo things. So, okay, maybe some agile methodologies. After all, open source software and agile methodologies share many similarities. For instance, like they both have incremental cycle. They are both cooperative. Customers and developers work closely together. and they are both adaptive to last-moment changes. But not all of these can be applied because the open source, after all, is based on a network of the developers are just volunteers. They are scattered all over around the globe, so we cannot really follow all agile methodologies. But there are some points that you can pick from some methodologies. For instance, I've seen this really cool lecture about extreme programming, and we do follow, and I just realized we do follow some of them. And since we've started to follow some points, I think we are doing much better. For instance, we try to refactor the code whenever we can, whenever you have spare time. I cannot really stress how important the refactoring thing is, because it not only helps you to keep your code alive, it may help you to understand the code better. It may make to look you into the area of code that you are just trying to avoid. You could make the code, and you will make the code much more easier to maintain. You can even reduce the code in size. And I guess everybody knows how refactoring is actually good. Testing is really something that developers don't like, but I think we need to test whenever we can. Here at Libvirt, whenever either the developer himself or the reviewer will make sure that whenever you are introducing a new API or new feature or something, that there is a unit test or there are unit tests for that. And we really have grown this extensive unit testing module in Libvirt. We also have an integration test that we are running both publicly and privately at Red Hat. And we've switched to monthly release cycle, which really helps both customers and us because, for instance, our consumers, our upstream consumers, doesn't have to wait for too long for their bug to be fixed. So, I think we did some mistakes, but we've really learned from them. If you would take just one thing from this presentation, is that you should use the common sense because it's the best friend of you. And the third point is you should be nice to new contributors because, as you've seen, we struggle with the problem that we have. We don't have enough contributors for some drivers. I'm trying to change that with Google Summer of Code, but I'm holding my finger crossed. And after all, OSS is just a network of volunteers, so you should be nice to new people. And that concludes my talk. So if you have any questions, points to make.
First of all, there is a missing slash in thank you.
Oh, yeah.
So I was curious about what exactly do you think went wrong with XML, especially because, as far as I remember, the usage of XML in Libvirt is also what allows you to keep the structure of the objects internal.
Yeah.
I mean, the clients talk to the library a lot via XML instead of using C. And this also allowed, if I remember correctly, a lot of backport of functionality because it only occurred through new XML elements, not through new APIs. So I'm curious exactly what went wrong with XML and what would be the better solution.
Yeah, it's not a bad thing itself that we've chosen XML as our format to describe the settings of domains. It's just that sometimes the structure of the XML of some elements, where either some elements are badly named or they are in at some wrong place. I would place them somewhere differently. And then, of course, as you said, the backporting thingy, Libvirt does not expose what XML elements it understands. So if you have, it has been pointed out already by Markus that the version of Libvirt is just meaningless, or any project is just meaningless whenever you come to backports. So you cannot really know if you have a Libvirt of certain version what elements does it understand to.
Doesn't Libvirt have the schemas that are placed somewhere in the file systems? RNG or whatever the name is?
Yeah, it has some, but for a long time they have been broken, and just recently we've switched to, so let's say, enforcing mode, which is when you are defining a domain or communicating with Libvirt via XML. We firstly check the XML via our schema. But we haven't done that. We started doing that just recently. So hopefully, and it already has catched many errors in our schemas. No more questions? Okay, in that case, I finished slightly earlier than I planned, but I think that it doesn't really matter since I'm followed by a break. So thank you. Enjoy your break.